Water is always flat and level. It doesn't bend, it doesn't curve. In this video I'm going to show you how to use trigonometry to calculate distance between two cities. Remember, water is always level. On a level, flat level surface, you can always use trigonometry to calculate the distance between two objects or two cities. Let's assume this is a boat. I'm going to explain how you can calculate the distance between two objects. Let's say this is a boat or a vessel on the sea, and you have two objects on two different locations. One there, and let's say one there, one here. If you can measure the distance from the boat to the first object, let's say object A, and if you can measure the distance from the boat to object B, and you can also measure the angle between the two objects, you can always calculate the distance between the objects. It doesn't matter where you are, you can always calculate the distance between the objects if you know from your location to the object the distance between you and the object and the second object. And you can also measure the angle between those two objects, maybe with a theodolite or something like that. But you can just measure the one distance, measure the other distance, and then you can calculate the distance between the two objects. To calculate the distance between object A and B, you need a third reference point. And if you can measure the distance from the third location to object A, it doesn't matter where, and from the same location to object B, you can calculate the distance between object A and B. So let's assume we have a third location. Let's say here. This is object C. Any random location on the paper. If you can measure the distance from C to A, and if you can measure the distance from C to B, the angle between A, C, B, you can calculate the distance between A and B. So let us draw a line from C to A, and then we can measure the distance between C and A. So that's the line. And from C to B. If we can measure the distance from C to A and from C to B, we can calculate the distance from A to C. It doesn't matter, you can choose any random location. If you can measure the distance between those two locations, you can calculate the distance between A and B. So let's measure the distance from C to B. Let's say it's 17.3 centimeters. So this is 17.3, and from C to B the distance is approximately 10.6. It's 10.6 centimeter. we need just one more thing to calculate the distance between A and B. That's the angle between A, C and B. So we can measure the angle between A, C and B. As you can see, it's 52 degrees. So this angle is 52 degrees. And with this information, we have everything we need to calculate the distance from A to B. You have to draw an isosceles triangle out of these three different locations. If you have three different locations, you can always draw an isosceles triangle. So that's what we're going to do, and then we can calculate all the distances we need and degrees, so we can calculate the distance between A and B. So if you divide the angle, the 52 degree angle, in two, then you have two equal size angles, and from that you can draw the isosceles triangle. So this one is 52 degrees. It's 52 degrees divided by 2. It's 26 degrees. So this is the angle. Yep, 26 degrees. And now you can draw from point A 90 degrees angle to complete the isosceles triangle. So it means this distance is equal to this distance. Let's draw this as well. And now we have an isosceles triangle with 26 degrees for both triangles. This is 90 degrees, and the other opposite corner is also 90 degrees. This angle is the same as this one. So if this is 26, this is 90, this should be 64 degrees, because 64 and 26 is 90, and 90 is 180 degrees. So it means this angle is also 64 degrees. What we would like to do is to measure the distance between A and B. This is what we want. The distance between A and B. So now we have a few triangles and an isosceles triangle, and we can, if we have, let's draw one more triangle from B, exactly 90 degrees. So now if you have if you can calculate this distance, let's say y, and if you can calculate this distance, so let's call it x, then you can calculate A and B. So let's call this center line, or the middle line, let's give it a name M, the middle line, ML, middle line. It divides the isosceles triangle in two equal size triangles. And now we can calculate this distance, let's say from A to, let's call this one M1, the middle line, number 1, this spot. Now we can use the sinus because we have the 26 degrees and we have the distance, the 17.3 centimeter, to calculate the distance between A and M1. Let's call it X1. The distance between A and M1, let's call it X1. So calculations will be the sinus of 26 degrees is equal to A M1, so that is this one, divided by A to C. So this distance divided by this distance, and that is the sinus of 26 degrees is equal to AM1 is X1 divided, and AC is 17.3 centimeters. So X1 is 17.3 times sinus 26 degrees. X1 is, if you calculate the number, it's better to leave it like it is. Just save it in the memory with all the digits. You can use your iPhone to do the calculations. If you just rotate it, you need a more complex calculator. Yeah. So it's going to be 17.3 times 26 sinus is, so the distance is 7.58. You can better save it in the memory, but try not just to leave it like this with the whole, all the digits. It's far more accurate. So the next step, how can you calculate this distance? Let's call this one E from this point. So M1 to E is the same as B to the middle line. So if you draw a 90-degree angle to B, this one will be 90 degrees, and now you can calculate this distance. Let's call this one M2 to B, because you have this distance, it's 10.6 centimeters. You have the angle, 26 degrees, so you can calculate this distance from M2 to B. Let's do that. Again, we can use the sinus to calculate this distance because we have the angle, it's 26 degrees, and we have this distance that is 10.6 centimeters. So it will be the sinus of 26 degrees is equal to M2B divided by C, the distance from C to B. So the sinus of 26 degrees is, let's call this one X2. Okay, let's do the math. You can use your iPhone, just rotate your iPhone, and you can use it's 10.6 times 26 sinus is, it's 6.64 centimeters. So this one is X2, 4.64. 646 centimeters. Again, it's much better if you just save the whole number it will be much more accurate. So now we have MB is the same as M1 to E. So this one is also what's the number? It is 4.646 centimeter. So now we have the X distance from A to E. We only need the Y, and then we can calculate, we can do the math and figure out what's the distance from A to B. So X, that is the distance from A to E, that is X is X1, that is X1 plus the X2. It's the same distance as M to B. This is X2. So it will be 7.58 plus 4.64. So X is, and you can do the math, and again all the digits, it's much more accurate. Let's name this spot F. So if I want to know the distance between E and F, M1 to F is the same distance as A1, as A to M1. So it's the same distance. It's an isosceles triangle, so it's the same distance. So we can calculate the distance between E to F. So it's going to be 7.58 minus 4.646. So EF is the X1 minus the X2. X1 minus X2, and that is 758 minus 4.64. So now we have the EF as well. So we did the math, and E to E, the distance between E and F is 2.94 centimeters, and we can do the same with the distance from B to F, because from C to F is the same distance from C to A. So if this one is 17.3 minus 10.4, we have the distance B to F. So it is B to F is equal to 17.3 centimeters minus 10.6 centimeters. So now we have B to F too. Now we have all we need, because this angle, the 26 degrees, is the same as this one, because these two are parallel lines. So this angle is the same as this one. So this one is 26 degrees. If this is 26 and this is 90 degrees, so this is 64, is the same as this one, 64. So now we have everything we need to calculate the y. So you can use Pythagoras, or you can use tangent to calculate the y-lag, or the distance between E and B. Okay, let's do the math. In this case we can use the tangent. So it's going to be tangent of 26 degrees is the EF divided by y. Yes, and so y is EF is the 22.94 divided by the tangent of 26 degrees. And if you do the math correct with all the digits, you will get this number, 6.02. So this is the y. 6.02. Now we have this leg and we also have the y. So this is, now we have the x, we have the y. Now we can calculate the distance from A to B. Right, to calculate the distance from A to B, you can use Pythagoras. With Pythagoras it's AB. You can use this formula, and that is the 12.22, and y is 606 and the square root. Or you can calculate this angle with tangents alpha is equal to y divided by x, and the y is the 604, I think, divided by the 12 to 2. And if you did the math correct, you can find an angle of, I think it's 26.2141, etc. Again, leave it with all the digits. So this one is 26 degrees, 26.2 degrees. And now if you have this one, you can also calculate the distance from A to B using the cosine. Let's use the cosine to calculate AB. So it's a cosine of the 26 degrees, it's 26.2, is equal to the x divided by AB. AB is equal to x divided by the cosine of 26 degrees. And if you did the math correct, it's 12 divided by the cosine of 26, and AB, if you did the math correct, it will be 13.6328, something like that. To be sure, because this is what we calculate, the distance between A and B, this is a correct scale, so if we measure this distance, it should be the same. So let's measure the distance between A and B. We calculate 13.6, and if we measure it, beautiful. Let me see if I can zoom it in. .6 centimeter. Perfect. So this is how you can calculate a distance between two cities on a Gleasons map. You need one, you can measure the distance or calculate the distance from the North Pole to the city, and then from the North Pole to the other city, and then you can do this math and calculate the distance between the two cities. Now you know how to do it. In my next video, we're going to calculate the distance between two cities. Thanks for watching. And remember, water is always level. It doesn't bend.